Few days ago, I saw a beautiful effect from one author, Hardwired House, that was showing a ballooning geometry, and the ballooning was divided by cells. Let's try to recreate this effect. I switch from Redshift to standard render to create a new shader. Then, going back to Redshift, for this material I load surface, tiles, and apply to our geometry. Now we have cells, and we need to customize them. Open it and change color to black and white. So black borders, white cells. Playing with scale to match our geometry, and maybe offset it to the side in shader. Yeah, like this, not to cut the nose. I hit in N, B to show the wireframe, and we don't have much of polygons, so I apply a closed surface and an object increase subdivision value. For further simulation, we need to create new vertex map that will be driving the cloth. Creating first vertex map and name it pin. Now we're going to fields, uncheck use deform points, and we will use our shader to match our geometry and to generate pins. Creating shader field, and instead of custom shader, I pick up the color option and need to put here a tag with our materials. Now we immediately see how it is applied to geometry, increasing subdivision for more dense wireframe. And one more vertex map to drive the ballooning. Rename it to balloon. Unchecking use deform points, create a sphere that will initiate the position of our growing field. I create keyframes, extend the timeline, and I need one more keyframe to touch our geometry to create this start zone of further vertex map. Creating freeze, hit clear and set to grow mode. Change to add blending mode. Play, initiated by sphere, and then start to grow. I want to improve the growing and creating random field, and in freeze folder we have a radius, so we're putting as a child random field there, going to first frame and hit play. Now we see that our edge is randomly deformed. Increase the size in random field, and we have more fluid-like growing. To solve this, going to freeze option and extending the search radius to 15. Checking. Much better result, decreasing the strength and increasing the radius. Restarting and full growing tool geometry, that what we were trying to achieve. Effect strength is like a time scale. The higher value, the faster growing will happen. The lower value, the slower growing will happen. The lower value will slow the growing speed. I will stick with these settings 20 and 20, and we go to next step. We need to add our shader to this field list. So we're dropping shader field and setting blending to multiply, checking the growth, and everything is working well with cutting our cell borders as we planned. To start the simulation, we need a simulation tag. I will pick the balloon one, going to surface and extend bendness and stretchness to a higher value, and maybe a target length with our balloon map in it. The same map to balloon parameters and extend the time of ballooning. Start the simulation, and everything is going down, so I need to go to first frame, Ctrl D, simulation, scene, and set gravity to 0. Let's decrease subdivision to 2 for faster preview. Checking how vertex map working. Everything starts to deform. so technically everything is okay. Select balloon tag, tweaking the overpressure, maybe to 1.2. And in mix animation with pins, I will pick and load our pin map, decreasing influence from 100 to something lower to help engine work better, because sometimes the 100% provides a lot of bugs. Restarting, and that's the effect. We need to tweak our tag a bit, maybe decrease the influence, increase bendness and stretchiness. Going to first frame, hit play, more aggressively pressuring, maybe target length something higher, and increasing our subdivision to 3 for final test. Going to first frame, hit play, observing, tiling, ballooning, growing, everything is going perfectly. It's like a chocolate bars segmentation. Going to first frame, selecting our shader, and I want to demonstrate that this setup will allow us to change the settings of a shader, and it will drive the vertex map and next simulation. So we can play with beveling, and immediately our vertex map will be changed. Going to first frame, rechecking. Now we have bigger cells and less pin zones, so there is a significant difference in simulation. Very fun and weird, especially with the face. So I will go to first frame and go back to a lower global scale value for our cells. Going to tag, increasing the pressure, maybe decreasing the time to have more aggressive ballooning. Hit Ctrl D, go into simulation and increase the iteration sub-steps to raise the fidelity of simulation. Damping I will up to have more viscous environment and much more damping in energy of our simulation, because I need our ballooning to be stopped. One more test. We have a huge drop down in performance, but I don't see any bugs or maybe penetration of these inflated zones, so I think it's working well. Stop the animation, going to our balloon tag, cache, and calculate cache. Checking the real speed. Very fun, very fun. That's the effect I was trying to achieve. So the next step is to render this thing out. I will use Redshift render, so open the render view, hit play. The next step is to build the setup, pausing the IPR, creating a plane, move it to the back of our shape, extend it, and creating few lights, one at the left, another at the right. Fast forward, going to materials, and I need to pick the cloth one, materials, fabric, and there is a library of presets. Picking the yellow one and applying to cloth surface. Waiting of applying, and I mistaked. Move it to male geometry. Closing the asset browser, hitting play in IPR to see how it looks. It's over bright. The next step is to tweak the light. L for left and R for right. Finding proper intensity. 10 and 15 looks to be okay. Increasing tiling of our shader. Looks gorgeous. Few adjustment to the lighting. Moving to the front, the left one. Extend it. And when we're scaling up our light, we need to decrease its intensity. But now we're moving the camera up, changing to a very telephoto lens. Okay. Also, I want to change the background, creating a new shader, applying, decreasing the roughness. We don't need any reflection in the ground, using color picker and find a warm color to match the main geometry. A little zoom out, tweaking the light for rendering, decreasing the intensity as I said previous, creating new area light, move it to the top, rotate it, playing with intensity, a very low value like 5. Looks okay, extend it, move it to the front, decreasing the intensity to a lower value like 3. Good preview. And in shader, I will go to node editor and increase the bump map because we have different scale than preset upper set. And I want our fabric to be more noticeable and visible. Beautiful, maybe 0.5 for the final result. Great. Checking buckets. Few tips for improving render speed. Going to Redshift. Enabling RTX. Going to advanced system and increase the size of buckets. And in basic setup, I need to decrease the global illumination maybe to 1 because it's very open scene. We don't need extra bounces. We don't have any reflection, so cutting to 2, almost no reflection, and combined depth should be a lower value 2. Just an average numbers. I don't see any difference in appealing. So let's check. Very low render time. For our test render, I increased the threshold to 0.2 after the point. 6 seconds. Let's save it to not sequence but MP4, disabling alpha channel, output all frames. Let's do a test render. Looks okay, but for a real test, I up threshold to 1 and decrease a resolution to half, 360 to 640. Let's play, and now we can check our animation. We have some jiggling, but overall it's a great thing, beautiful lighting. Few bubbles are doing something weird, and I think we can adjust the settings to solve this problem. Let's go and do this. Ctrl D simulation settings, upping the damping to slow down our simulation. Now it's set to 5. I would up it, maybe 10 should be okay. In balloon we will play with expansion time, maybe 60. The next step is to cut the timeline. For final rendering, I also add a Redshift tag, rendering, RS object, and in geometry add 1 into subdivision to smooth the geometry. I think that's it. And now we can go and calculate our cache for final result. Hope you like it. See you in the next video, but don't turn this video off because in few seconds you'll see the result of the final simulation.